Good afternoon. My name is Weihang Su, and I'm from Tsinghua University. It's my honor to share our solution to the Wisdom Cups this year here. At the beginning, I would like to give you a brief introduction about our team. We are the THUIR team from Tsinghua University. We have 3 team members, including me, Jia Chen, and Haitao Li. And we are under the guidance of Professor Qingyao Ai and Yichun Liu. We participated in both unbiased learning and pre-training for web search task, and we achieved the 2nd place in both tasks. So the following of my presentation will be divided into the following 4 sections. Now let's go to the first section, task description. Actually, these 2 tasks are quite similar because they adopt the same training set and the testing set, and both of them are re-ranking tasks. For each query, the following information is provided, such as the query content and search frequency. And for each candidate document, the title and abstract is provided. And as for the evaluation metric, they adopt DCG metric, which is defined here. Note that there are only a few differences between 2 tasks, and I will introduce that later. Now let's take a look at the dataset. As we can see, 3 datasets are provided, including the pre-training dataset, validation dataset, and the test dataset. The only difference between 2 tasks is that the validation dataset is not allowed to fine-tune the ranking model. And in the pre-training for web search tasks, the validation dataset is allowed to fine-tune the large ranking model. And as for the pre-training dataset, it's a really large data set. 1.2 billion search sessions are provided, and it also provides some information, such as some original semantic features, including the query and the candidate's document on that search engine result page. And also some display information is provided, such as position, displayed height, and the most importantly, the user behavior information is provided, such as the click information, and the debugging time and display time. As for the expert annotation dataset, it is a collection of labeled query, which is annotated by expert according to the relevance. And the following features are provided. And most importantly, there is an annotation label range from 1 to 4 according to the relevance. And the test dataset is almost the same as the validation dataset. The only difference is the expert annotation label is not provided, so we have to label them by our ranking model. Next, I'm going to introduce the method of our solution. Our method can be divided into the following 4 parts, including pre-training and fine-tuning, which is a very popular paradigm nowadays. And also we have feature extraction, and a learning to rank method is adopted to ensemble all those features together. Now let's take a look at the pre-training step. Here is an illustration of our pre-training and fine-tuning framework. Firstly, we pre-train from scratch according to the search engine log, and we have those features that I introduced before. Based on those unsupervised learning strategy, we can have a pre-trained re-ranker. And the pre-trained re-ranker has the relevance matching ability in the pre-training stage. And after the pre-training stage, we fine-tune the model with expert annotation dataset. And obviously, it has a higher performance compared with the pre-trained re-ranker. So the core of pre-training is the pre-training task and the pre-training objective. So before pre-training, we first analyze the following question. What ability should an ideal re-ranking model have to solve the web search task? According to our analysis, we believe that an ideal model should have the following ability. Firstly, and obviously, this model should understand the natural language so that it can understand the query and the candidate documents. And besides, an ideal model should also have the ability to measure the relevance between the query and documents. Well, this is an important ability to solve information retrieval tasks. So we want our model to have those abilities, and we design the pre-training tasks based on them. And to be specific, we adopt the MLM task to make the model understand natural language. And we also adopt 2 tasks to make the model have the relevance matching ability. Now let's take a look at the MLM task. Well, MLM is a language model trained to predict the missing word in a sentence based on its surrounding words. This is done by masking some of the word in the input text and train the model to predict the masked word based on the context. Well, this is a very classic NLP task, so I won't go into detail. The point is, after the MLM task, our model have the ability to understand natural language. Next, to make our model obtain the relevance matching ability in the pre-training stage, we design an unsupervised learning task called point-wise relevance matching. Well, this task is actually simple. It is a binary classification task, which aims to give a score. And this score represents the probability of the document being clicked. The higher the score given by the model, the more likely the document will be clicked, and the more likely the document is going to satisfy users' information need. And we also adopt a list-wise relevance matching task based on contrastive learning. In this task, we define the clicked document as the positive example, and all the non-clicked document as the negative example. Obviously, the positive example is more likely to match users' information need. And this task is based on contrastive learning, and the loss function is defined here. After the pre-training stage, we fine-tune our model based on the expert annotation datasets. Well, we also tried two types of fine-tuning strategy. First of all, the point-wise fine-tuning strategy. Firstly, we pre-process the 5-level label to a binary classification task. To be specific, we define the document which has the score 3 and 4 to relevant, and define the document which has the score 0 and 1. We define that as irrelevant. And we use a classic point-wise loss function to optimize our model. And besides, we also tried a list-wise fine-tuning strategy. This table shows our contrastive sampling strategy. For each document with score more than 0, we define all the documents with lower score as negative examples. This process is illustrated in the red picture. For the loss function, we use a softmax cross-entropy loss to optimize our model. And this loss function trains the model to give a higher score to the positive document and give a lower score to the negative document. So next is the feature extraction part. Well, to further improve the performance of our re-ranking pipeline, we extract more features of each query document pair. Well, including some basic features such as the length of query, title, content, and the query frequency. And besides, we also tried some lexical features, including some traditional methods such as BM25, query likelihood, and term frequency. Well, we finally extracted 24 features. Due to the time constraints, I'm not going to introduce them one by one. So welcome to read our paper to get more information. And finally, it's the learning to rank part. The learning to rank method aims to ensemble all those features together. The input to the model is a vector of those features, and the output of the model is a relevance score. To be specific, we tried 4 learning to rank methods, including coordinate ascent, lambda mart, XGBoost, and light GBM. And next, let's take a look at the performance of our proposed method. Well, here's the screenshot of the leaderboard. As you can see, we achieved the 2nd place in both tasks. However, there's a relatively large gap between our result and the champion. So I'm really looking forward to their report next. Here are some of the experimental results. As we can see, the best single model is BM25, which is has the score of 10.3. And we can also observe that ensemble more feature can further improve the performance for about 10% compared with the best single model. We also tried the combination of those features, which is shown on the left. And as I mentioned before, we tried 4 learning to rank method. Here are the performance of each method. We can observe that with the same input feature, the differences between those models are not significant. And the light GBM model has a relatively better performance. And finally, I'd like to show you some conclusions. Obviously, designing pre-training tasks tailored for web search it can significantly improve the retrieval performance. And it's in the real industrial environment. And incorporating lexical features such as BM25 in the retrieval pipeline can further improve the model performance. And however, due to the time constraint of the computation, there's still many methods that we have not explored yet. So in the future, I think we will explore the pre-training method based on the same dataset. For example, we can try to use the satisfied click instead of all the click. As I mentioned before, we treat all the clicked document as the positive example. However, the click document may not satisfy user. So we can explore some satisfied click, such as the first click, the last click, and we can explore the difference between the document which has the longest browsing time and the shortest browsing time. Well, I think we will explore that later. And we can also explore something about session search. Well, session search aims to provide an optimized document ranking list by utilizing the user behavior information in the same session. We will explore that later. So that's it. That's all of our solution to the Wisdom Cup. Thanks for listening.